Hey guys, Mrs. Traver here. Today we're going to do solving multi-step inequalities. Our learning target is that we can solve 2-step inequalities as well as 3 and more step inequalities and represent them on a number line. We know we'll be successful when we can isolate the variable and then use greater than and less than to graph it. Let's go ahead and jump in to the first one. We're going to have 5 examples on this lesson. So what I want to notice first off is the way this is printed on your assignments is that the number line is directly under the problem, which is a little bit in the way, but we can work around it and we can kind of just like skip this line of work here. So my first step is that I need to combine these like terms. On the left I have negative 7a plus 4a, which I can combine them to be negative 3a. So I'm just going to kind of boom, jump over here. I'll drop down everything else. And then lastly, to solve, we need to get rid of this negative 3. It's being multiplied, so I'm going to divide by negative 3 to cancel it. So dividing by negative 3 on both sides is a red flag to me. Whenever I divide or multiply by a negative, I need to not only do the operation, but I need to go from the less than or equal to the greater than or equal to. So I'm switching the sign. At this point, I can graph it. I would have a closed dot at 5. And I'm going to shade, in this case, since it's greater than, to the right. Let's try the next one. Number 2. On the left I have 3k minus 4, and on the right I have 5 minus 6k. So I have variables on both sides. So let's first work on getting them to the same side. I'm going to add 6k to both sides to make that happen. On the left I now have 9k minus 4, and on the right I just have 5. Now that the variables are on the same side, let's move the numbers to the other side by adding 4 to both. On the left I have 9k, on the right I have 9, and lastly to solve, let's divide both sides by 9. So we have k is less than or equal to 1. Since it's at 1, we will go up here to the 1, and it's a less than or equal to, so we'll do a closed dot, meaning that it could equal 1. Less than or equal to would be shading to the left, so everything on the left side of the graph would be shaded in. Let's try number 3. This one's got a few more things going on. On the left we have 4 minus b plus 7. On the right we have 2b plus 2. I notice on the left there's some combining like terms I could do first, so I'm going to do that by combining the 4 and the 7 to get 11, and I'll drop down everything else. Minus b less than or equal to 2b plus 2. Now that everything's consolidated, let's try to get all the variables on the same side. I'm going to add b to both sides to put all of them on the right. On the left now, I just have 11. On the right, I have 3b plus 2. Now that the variables are all on the same side, let's move the numbers to be on the other side. So I'm going to subtract 2 from both. 11 minus 2 gives us 9, is less than or equal to 3b. And lastly, to get the b by itself, we'll divide both sides by 3. So I now have 3 is less than or equal to b. I like to put this in the order where b is first and the number is last, so I switched it. When I do that, I have to switch the sign. So instead of less than or equal to, it's now going to be greater than or equal to. Now I can graph. I'm going to have a closed at 3, since it was the or equal to, and greater than means shade to the right. That's it for number 3, 2 left. Number 4, negative 96 is less than negative 4 times the quantity 4 plus 5p. I need to first get rid of this parentheses, and I can do it in 2 different ways. I could distribute, and then I'd have to work from there, or I could see if I can get rid of the negative 4 right now by dividing both sides by it. I think that's the quicker way. So let's divide both sides by negative 4 right now. The 4's would cancel. On the left, 96 divided by 4 is 24. Or I should say negative 96 divided by negative 4 is 24. Since I just divided by a negative, I'm going to switch from a less than symbol to a greater than symbol. And I'm left with 4 plus 5p on the right. I now have no parentheses, so that's nice, and I can work on solving this 2-step equation by first subtracting 4 from both sides. 24 minus 4 is 20. So 20 is greater than 5p. Lastly, I'll divide by 5 on both sides, and I'd have 4 is greater than p. I need to put this so that the variable's on the left, so I'll switch it around. instead of a greater than symbol, it's now going to be a less than symbol. So I'd have an open dot at 4, and less than will be shade to the left. All right, our last problem, number 5. 26 minus 8x is greater than 8 times the quantity 6x plus 4 plus 2. Now, on the last problem, we got rid of the parentheses first. On this one, it's not the only thing there. There's also this 2 hanging out. So let's take care of that first and move it to the other side. I'm going to stack it with the 26 so they can combine. And I'd have 24 minus 8x on the left. On the right, I have 8 times the quantity 6x minus 4. All right, now I can't do what I did before where I divided by 8 as easily because I have 2 terms. I can still do it, but I just want to make sure if I'm dividing by 8, I'm going to divide every single thing by 8. So this one, and this one. A couple things will cancel. These 8s will cancel, and so will these ones. 24 over 8 will become a 3, and I'm going to drop stuff down. Minus x greater than 6x minus 4. Now I have a 2-step equation left. Let's get the variables on the same side by adding x to both sides. I have 3 on the left, and now 7x minus 4 on the right. To finish out the problem, we're going to add 4 to both sides. On the left now we have 7, and on the right we have 7x. Let's divide both sides by 7 to get our final answer. We'd have 1 is greater than x, which we can switch around to be x is less than 1. We'll do an open dot at 1, and we'll shade to the left. That's the last problem for today. I hope that the multi-step solving inequalities worked out well for you, and I will see you next time.